Hi class, this is Ms. Aguirre. I'm going to go over in-class activity 2E. This is the extra credit section, but it's a awesome activity for those of you that may be doing advanced or experimental design. So in this activity, you will understand the purpose of blocking, the importance of well-designed experiment, and you'll be able to describe the role that blocking plays in an experiment. You'll be able to identify the basic principles of completely randomized block design, and you'll be able to describe how to use a completely randomized block design for a given research objective. So it says, first question, in the last few activities you have been exploring key components of well-designed experiments. Another key component of well-designed experiments is randomization. Let's revisit the polio experiment from the previous assignment 2E. What role did randomization play in this experiment? So you might need to go back and click on the preview assignment. But the preview assignment kind of had this here. And I wish I could expand this more, but I made, it actually does not control. Oh, there we go. There we go. Okay. So in the previous assignment for 2E, you have the experimental units. Let me just check that it's recording. Yes. Here we have, in total, the population is 401,974 subjects, and they were randomly selected, or assigned, I'm sorry. So they were randomly assigned to two groups. One group is the experimental group with 200,745 subjects, and the other one was to the control group. It had 201,229 subjects. And then you compare the results of that polio vaccine. So they were given a vaccine, the experimental group, the actual Salk vaccine. They were given the actual Salk vaccine. I'm sorry, I'm using a mouse and it's actually really slow. Okay. And then the control group was given something almost exactly, looks like the exact pill, the exact same color, smell, taste, but it was a placebo. So they did not get the actual Salk vaccine. But you have to make sure these two groups are exactly the same so this experiment works well. But this was just a placebo, like a fake pill, and then you tested the results and compared the results. So what role did randomization play in this experiment? By using randomization to determine which subjects are assigned to the experimental group and which subjects were assigned to the control group, comparable groups were formed to balance the groups receiving the Salk vaccine with those receiving the placebo. So again, back to the image, this image, control. So you do random assignment, that's what randomization is. If you do random assignment, not random selection, but random assignment, you assign equally these subjects either to the experimental group or to the control group. So everyone has an equal chance of being in either of the groups. Okay. So this is the objectives. Now let's move on to question 2. Another way a researcher might conduct an experiment is by using a completely randomized block design. This design is used when the experimental units are divided into homogeneous, they look the same, homogeneous groups called blocks. Within each block, the experimental units are randomly assigned to treatments. Complete the following diagram to illustrate the design. So I'm going to try to do my best to draw on this, but I'm going to see if I can insert from a Word file. It's not going to let me. I'm supposed to put the word randomize selection. So let me just go ahead and do a snippet instead so that you can see the filled in values. Oh, come on. My mouse is not working here. Oh, No, we don't want that. Oh, we don't want that. Okay, there we go. All right, so here we have block 1 and block 2. Then from each of the 2 blocks, we're going to randomly assign them into the experimental group and the control group. This one receives the treatment, the actual Salk vaccine, and this one does not. And then we compare the results. In the block 2 should look exactly the same. That's why it's homogeneous. We randomly assign a subset of this group, block 2 people, and into the experimental group or the treatment 2 that receives a placebo. And then we compare the 2. All right, so this is control group. They don't receive any, they receive a pill, but it does not have any type of vaccine. This could be a different type of vaccine or a different way to treat polio. So that would be the treatment number 2. Okay, so that's how you could do a completely randomized block design. So move on to question 3. It says a school psychologist wants to test the effectiveness of a new method for teaching reading. She recruits 80 first grade students in district code 75104 and randomly divides them into 2 groups. Group 1 is taught by means of the new method, while group 2 is taught by the traditional method, like a lecture, right? The same teacher is assigned to teach both groups. At the end of the year, an achievement test is administered and the results are compared. What is the factor of interest? What is the response variable? So some of those were discussed in the definitions in the previous assignments. So let me just, oh my goodness, it's not going to let me highlight or anything here. Oh, because I'm in the draw. Let me go ahead and, no, it's not. Let me go ahead and save this. Sometimes that helps. Save this to semester, spring of 4 with solutions. Okay, there we go. Now we got all my menus back. All right, so what is the factor of interest? The factor of interest is the teaching method. That's what's going to change. So the factor of interest is the teaching method, right? They're going to be trying out the traditional method and trying out the new method. So group 1 is going to have the new method, and group 2 is going to have like the traditional lecture method. Okay, so let me just highlight this maybe with a different group. Right, so group 1 is going to have the traditional method, and group 2 is going to have, group 2 is going to have the traditional method, and group 1 is going to have the new method. So what is the response variable? What are we looking at the end? So the response variable is the score on the achievement test, right? That's what they said here. An achievement test is administered and the results are compared. So B, what are some factors other than the factor of interest, other than the teaching method? So what are some other factors, not the teaching method, in this study that could affect test scores? So what else could affect test scores? How are they controlled? So the first question, what could affect test scores? So just in general, what could affect test scores? So some factors include maybe grade level of the student, their intelligence, if they studied, very good. School district, maybe rich or poor, and maybe teacher, right? Do they dedicate more time to you to answer your questions or not? So how are they controlled? So they are controlled by fixing the teacher. What does that mean? The same teacher will be teaching both group 1 and group 2. That's fixing the teacher. Okay? The grade level, all first graders or second graders or third graders. So they're just going to look at that method. I don't know what grade level, so I'm assuming this is a K through 12. So we're going to control that by making sure we only get these teachers in one grade level. And then maybe also school district, right? We're all from district 75104, 75104. So let's see. If they studied, that's a hard one to control, but it could be controlled by saying all the students are going to study for 2 hours before taking the test. So that's how we can control that between the two groups. We want to make sure the two groups look exactly the same. We want to make sure that this group and this group and this group and this group do the exact same thing. They get the same number of hours, they have the same teacher, they're all from the same grade level. So that's how we can control this experiment. The only thing that's going to be changing is the teaching method, and that's what we're going to test. So what are the treatment groups? So there are actually two treatment groups. What are the two treatment groups? The new method and the traditional method of teaching reading, right? This is a reading class. The new method of teaching is the treatment of interest, right? All right, so there are two groups. One is the treatment method, one is the treatment group, and one is the control group, right? One is the traditional. So what are the experimental units, or what are the subjects? So the experimental units, or what we call the subjects, are the 81st graders in District 75104. I didn't read the question carefully. So she recruits 81st grade students in district code. So this is our units, our subjects, 81st graders. Are there any factors that cannot be controlled that might affect the results? Let's think about this. Are there any factors that cannot be controlled that might affect the test results? So what else could affect the test results? I can minimize the effects. How can we minimize those effects that this variable may have in the outcome? Okay, so very good. So getting enough sleep. How can we minimize the effect of this variable? You can only recommend, but I can't force everyone to sleep at night at school or something, but maybe recommend everyone get a good night's sleep the night before the test. What else? What are any other factors that can be controlled that might affect the test results? Okay. The book actually has a weird answer. They have gender as a factor that cannot be controlled, that might affect test results. Maybe one gender talks more than the other gender, right? One gender reads more than the other gender. I'm not sure why they put that one as a factor that might affect test results. Let's see, I can think of what else can affect the test results. We also mentioned studying. Okay, so studying. So studying before the test. So how can we control this? We require all students to go to maybe 2 hours of tutoring before the test. Okay. All right, so there's many others factors, but those are 3 we listed here together. So finally, the last question. In previous research indicates that girls and boys may react differently to the 2 methods of instruction. There are an even number of girls and boys. So they have, remember, a bunch of researchers created these lessons. So the previous research indicates that girls and boys, so they already knew there was a gender inequality here on this study. So they tend to react differently to the 2 methods of instruction. There are an even number of girls and boys. How can you design an experiment that will control the effect due to gender on the scores on the achievement test or the response factor? Complete the following template to illustrate your design. So here we have block 1, block 2. So we have equal number of boys, an even number of girls and boys. Okay, equal, not even. So let's see. How many total students were there? There were 80, right? So if we want the equal amount, that would mean I would need how many students, how many in first block and how many students in the second block. If we want to test the effect due to gender. So you're right. In this one, we would have, let me see if I can insert a text box here. Let me see, draw a text box. I'm going to put, no, it's not going to let me. So let me again copy and paste my answer here and show you that's not it. All right, so last question for the day, Control Shift. So there were 80 kids, right? So 40 girls and 40 boys. So that would be your 2 blocks. And then from each of the blocks, just like you saw that in the activity we did in class where you did the 3 high schools and then by age would be the second breakdown. This is a well-designed experiment would have the girls on 1 block, boys on the second, and you randomly assign girls into the experimental group, which is group 1 that is getting the new way of reading and a new teaching method, and the control group is the one that receives a traditional teaching method. The same thing with the boys. This would look the same, and then you check the achievement test results for both. Okay, so that's how we would fill out that question number on part F. So what are some advantages of using the completely randomized block design? Completely randomized. There's a lot of subgroups, right? So the advantages of using the completely randomized block design include blocking and randomization. Okay. Let me just type that here. Okay. Blocks are formed by gender because previous research indicate that girls and boys may react differently to different teaching methods. So this is when you're doing on a study, working on a master's or a PhD program, you got to look at previous history. So what can we do from previous research? And then blocks are formed by gender because previous research indicates that girls and boys may react differently to different teaching methods. Blocking is useful because for example, the majority of the students who perform well on the achievement test are girls. The researchers would know how to attribute the difference in performance, and each block contains the same gender. So if gender has an effect on the achievement test, it can be easily identified. So in this case, gender is a nuisance factor, and we see that blocking reduces variability due to gender. So let me just write that down. Let me write that down, see if I can. So gender is a nuisance factor. That's the word I wanted to spell out. It's in the previous assignments. That reduces variability due to gender. Now, when using random assignment to assign the first graders to experimental group and the control group, the researchers are able to clearly recognize the effect of the new teaching method and the effect of the traditional method. So by using the random assignment for the girls, random assignment for the boys, we get that effect. We can see that effect. So question 5 now. Would you consider the experiment to be well designed? The answer is yes. It does seem to be a well-designed experiment since it includes a control group. The experimental units are randomly assigned to treatments, and the subjects do not know which treatments they are receiving, right? So they're blinded, and replication is also achieved. So I'm going to leave that there. There we go. You can pause and write that down. Would you trust the results from the conclusions of this experiment, or would you be skeptical? Yes, I would trust the results of this experiment. Why? It seems to be well designed. It's a key component. If it's an experiment, it's well designed, the results are meaningful and trustworthy, right? So we need to know what is a meaningful and well designed experiment. So let me just list them for you. I had them already typed, and for some reason my file didn't come out. So let me just again snip this and show you from the previous assignment what is a well-designed experiment. And a well-designed experiment from the previous assignment has these components. A well-designed experiment has replication, right? You repeat it hundreds and thousands of times. Control group. You also have in a well-designed experiment, you also have a control group, randomization and assigning experimental units to treatments, and blinding, right? The experimental units are the subjects of the experiment, and the treatments are the experimental conditions imposed on the experimental units. One of these may be a control, the placebo or existing treatment that provides a basis for determining whether a particular treatment is effective. The treatments correspond to the values of the factors of interest. So basically what we did in the drawing that we had here, where we had the girls, boys, and we randomly assigned them into experimental and control groups, and we made sure we controlled all the factors, right? We had the same teacher teaching both. We had the same age for the students, and they all studied the same number of hours for this exam, and so all of that can be controlled. So would you trust the results? Yes, simply because it's a well-designed experiment. So do know all the factors of a well-designed experiment. Okay. All right, that is it. I will close this off. Please finish the preview and practice if you want the extra credit for this section. This is section 2E, and in 2E we have these objectives. You'll be able to describe the role that blocking plays in an experiment, identify the basic principles of completely randomized block design, and describe how to completely randomize block design for a given research objective. So this is used a lot in research, randomized block design. So it's good to know. So thanks for watching, and we'll see you next class. Go ahead and move on to the preview assignment for 3A.